This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. Last time, I drilled a bunch of holes in the variable power supply's printed circuit board. In this video, we will fill up the holes. I'm going to start off loading this board, doing resistors first. Resistors and jumpers are the least heat sensitive. I'm using a horizontal mount for that first resistor, and the subsequent few resistors are being mounted vertically. Mounted vertically to conserve real estate, and horizontally so that I can route leads under the resistors. The larger wattage resistors require bigger holes, and so we drill them out. Most of the components can be mounted with the existing holes. Mounting the least temperature sensitive components first, resistors, jumpers, and then later capacitors and so forth, and winding up with the most temperature sensitive components. My feeling is that once the component is soldered, it is going to be picking up heat from anything else soldered on the same trace, and so the first ones mounted will be more likely to pick up heat. I want them the least sensitive to that heat. Using a solder flux pen, which is just neater than the liquid flux I use for larger components. Judging from the way this smoke is going, I've once again forgotten to turn on the fan. Oh, what can you do? So we wet the soldering iron, facilitate transfer of heat. Apply the soldering iron to both the component lead and the pad, and then touch the solder to the opposite end and have it melt along the lead and the copper pad. I'm just trimming this off. It doesn't have to be particularly close. As a matter of fact, I probably don't want it all that close. I may have to desolder these things in a few years to be used for something else. Now, I've finally gotten to realize that I have some jumpers to solder in, and if I had my wits about me, these would have been the first things to get put onto the board. They're temperature insensitive, and they're low-lying. Don't get in the way of anything else. And it does represent a routing problem. Suppose I could have routed the two traces that are being jumped, could have routed them behind the transistor, but that would introduce a whole set of other problems. Now for the capacitors. I have disc capacitors, ceramic disc. And tantalum, and larger electrolytics. These are relatively temperature insensitive, but you can't keep the soldering iron on there for long, particularly for the electrolytics. Just heat up the capacitors and the electrolytics will blow up. And now just clip off the leads, get them out of the way to allow soldering something else. A lot of the technique in the soldering is really clearing the way to get the soldering iron unimpeded entrance to the joint. And here's that small disc capacitor. That is the frequency compensation capacitor for the 723 voltage regulator. Now we're up to transistors. These things are sometimes really frustrating to align and mount. I'm using some canned air to spray and cool down these junctions because some of these transistors are fragile. The ones I'm using aren't particularly known for their fragility, but I do want to cool them down as soon as I can. Trying not to keep the soldering iron on there too long in between air sprayings. One of the transistors that I haven't shown being mounted is the 3055 planar transistor. There's a reason for that, and I'll have to get into it in the next video. Well, I've got the active and inactive components mounted and soldered, except for the IC. But before I do the IC, I want to drill and solder the wire leads that are going to come into and out of this board. The first thing I need to do is to make the holes bigger. I'm using, in general, number 18 wire, occasionally number 20 if I can't find the larger size. Stick the wire in, and I want to have some pressure on the wire. I'm pressing down on it when I solder. And this affords a certain degree of strain relief because it's pressing the vinyl insulation up against the top side of the printed circuit board. So there is a certain amount of strain relief afforded. Common negative lead coming in comes right into the integrated circuit and kind of disperses from there in a relatively thick trace. And now we get to clip excess leads. I save these leads. They're valuable for future work. Now, I've been thinking about this, and I decided that I'm going to spread solder over the copper traces. There's just too many of these traces that were undercut during etching and pitted, and my concern is their conductivity, and I figure, well, I'm going to coat these things in solder. I'll just pretend that they've been dip soldered. It's probably unnecessary, but anything that makes me feel more comfortable with this. The solder coating should increase the conductivity of these traces. Now I get to work on the IC, and I'm using an IC insertion tool, which makes life immeasurably easier. I'm soldering those pins that are not connected to anything first, and soldering on opposite sides. By soldering unconnected pins on opposing ends of the chip, we're stabilizing the chip so it's not wobbling around. I'm also liberally cooling down these pins with compressed air. This seems to be going fairly well. I'm using a relatively high temperature, about 325 degrees centigrade, not Celsius, and I'm trying to keep the soldering iron pressed up against the IC pins for a minimal amount of time. There's a lot of crud on this board, and I poured a mixture of acetone and isopropyl alcohol on a gauze square, and now I'm brushing it with an anti-static brush, and it really does a lot to clean up the mess. Makes the thing look much better than it did. Now, I've got a bunch of leads coming out of this board. I'm mixing up some epoxy glue, and I'm going to be applying the epoxy glue to the base of these wires and to the wire insulation itself, and get that glue to act as some additional strain relief. I've just been victimized too often by broken wires, where the solder creeps up the inside of the wire and the wire becomes brittle and breaks without you knowing it. In this video, I loaded, soldered, and trimmed components on the variable positive power supply printed circuit board. I started with the least temperature sensitive components. I cleaned the board with flux remover. I applied epoxy glue to the base of the wire leads attached to the board to provide additional strain relief. In the next video, we will test the board and proceed accordingly based upon the test results. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.